Right, good afternoon, everyone. Hopefully you've had a chance to recover from lunch and are full and ready to give your attention to this session on efficient design, efficient programming even. So I'd like to introduce our first speaker, Jakub Sobolewski from Epsilon, who's going to talk to you today about getting the most out of test-driven development for Shiny.
All right. Hello, everyone, and welcome to the session about test-driven development. I'm Jakub Sobolewski. I'm a senior R-Shiny developer at Epsilon, and I've been using test-driven development for 3 years now. I've used it to develop small, Shiny apps, prototypes delivered in 2 weeks. I've used it also to deliver huge projects that were developed over many months. I've used it also to develop our packages. So in this session, we're going to establish what we mean by test-driven development. We're going to see how we can do it in R, and I hope that by the end of the session, you will see why it's worth using this technique. So, what is test-driven development? It is a technique in which tests help us design our production code. It is a guided evolution with clear feedback after each step. And it is a technique in which we write tests first before we write our production code. There are 3 steps in TDD. Red is when we start with writing a failing test. And it will fail either because the production code doesn't exist yet, or it doesn't do what we want it to do yet. Green is the step where we write our production code. And what's important is that we write only as much production code to satisfy our tests, because if your code already does what you want it to, why would we write more? You ain't gonna need it. The last step is refactoring. So, were you ever afraid of refactoring because you might break something? When we start from writing tests, we can mitigate this problem. Tests will tell us if something goes south, and we can fix it immediately. So actually, tests empower us to make bold changes to our code base. And this is a step where we can make our code more readable, maintainable, or even more optimized. So let's take a look at an example. We will implement a simple function that adds numbers together. We will focus on the first behavior. So let's say that we want our function to sum multiple numbers. So how do we do that? And this first step was the most difficult part for me when I was just getting started with TDD, because how can I write a test for a code that doesn't exist yet? So it's useful to remember that there are 3 parts in each test case. It's setup, execution, and assertion. In the setup part, we can use those arrange, act, assert comments. We can just put them from the beginning, and it will guide us to fill in those blanks as we go. So we first focus on the setup. And this step is very powerful in this technique because it forces us to think about what we need to be able to solve our problem. So you won't start solving something unless you understand what are you really solving. In the execution part, you call your code. And the way you call your code from tests is the way you will call your code from the production part of the code base. So the way you write your function in tests is the same as all over the place. So you can take advantage of this fact and try out a few different approaches, see what works best for you. And in the assertion part, again, we need to think how to assert that our function does what we want it to. So it helps us understand the problem better. So then we start filling in the production code. When we add the function and it doesn't do anything, tests are still red. We can add a simple naive implementation and see that it works for this case. But what happens if we want this function to do more, to have more behaviors than just this one case? Let's add another case that we want it to work for a single number. Now we see that our tests are red. We implement a new version of our function that satisfies both. So we can incrementally add new behaviors and always get the feedback that it works as expected. And now, when we go to the refactoring part, we might use another function or just make this code more maintainable or easier to read. We are free to do any changes as long as our tests are green. And this was super easy. So let's see how we can use it, the same technique, to solve more difficult problems. There are two approaches. Bottom-up is where we start small, with the smallest part of the problem that we can solve. And we build our solution and let the design emerge from those small steps. The other approach is opposite. We start from top down. We focus on high-level objectives first. If we are developing a Shiny app, those high-level objectives can be behaviors of our users that we want them to be able to do in our app. So then we fill in the gaps until tests are green. And how do we select the approach? We select what helps us move fast. We select what helps us get feedback the fastest from our code. So this is what test-driven means. Tests are the driving force. They help us get the development momentum. And they also tell us if our code does what we think it does, because we have this reproducible way of checking that anytime. So probably you're working with your clients and you establish some requirements. So how do we get from those requirements to our test cases so then we can implement our production code? It's useful to remember to use specific examples because they help us understand the problem better and they are more easier to translate to test. And if we just talk about abstract descriptions, they don't have those properties. And this is what acceptance criteria are for. They are a list of concise, clear statements that we can easily verify. So if we frame our acceptance criteria as something should do something, or this thing should also do the other thing, we can very easily translate it to a test case, and we can use describe and it functions from test.dat, and notice how this code reads almost like natural language. This is what is it for. And it's also useful to remember that when we are focusing on very specific low-level functions, it's better to be specific in our test case titles. Instead of just saying that it works correctly, it's better to say, for example, that it should throw an error when a certain condition occurs. This is way more informative, and then you don't need to dive deep into code to check what this function actually does. And when we're talking about higher level tests as tests of a Shiny app or just a test of a Shiny module, then it's better to be abstract. So don't tie your descriptions to elements in the interface because those things may change. Those are details. It's better to be abstract and focus on the business goal. So instead of saying that something should appear after you click a button or do something in the interface, let's just say that we should show a dataset summary. And if we phrase our tests this way, they can show us that we solved the problem, and they can also document what we solved. This way, tests become a live documentation of our system, and it's always up to date because we need it to run, and this is how we get most out of our tests. Also, if we phrase tests this way, they can be a driver for communication with our client because we can use real data to talk about inputs and outputs of our system, and they can easily validate if what we are going to implement is exactly, precisely what they need. So, how we use test-driven development with Shiny. It is useful to remember that a testable unit of a Shiny app is a Shiny module. It's good to remember that we can use a module to encapsulate a feature and that we can run modules as standalone Shiny apps. So let's take a look at example. So we will implement a module that displays a summary of some dataset. We start from a failing test, and let's take a look how we set things up. We will call a dataset summary module that doesn't exist yet. We will wrap it in a Shiny app, so we will be able to run it in isolation. Then we will create an object that we will use to communicate with this Shiny app. So the point here is that we want to hide details on how we interact with this app and to provide human-readable methods that tell us exactly how we interact with our module. And let's say that we want to focus on the first render of the page. So when users didn't do anything yet, the first render of the app. So we skip the act part of our test, and let's go to the assertion, and we call it on our page object, and we expect that this summary will be visible. So now we might want to implement a skeleton of our module. Tests are still red. And now let's go to our dataset summary object. So you see that this is just a wrapper around Shiny test2 app driver object, and this object will just hide the information how we use certain methods to interact with our page. We, from our tests, are only interested in using the expect summary visible method. Something was skipped. Let me fix that. I need to scroll up. So at this point, we might realize that we need our module to get data from somewhere. So we might pass it to our module via a reactive or some other method. Let's say we have an API, a data provider, that provides the data with the get summary method that does all the summarization, and it contains all the business logic. So we might just provide a fake object that provides an iris dataset. At this level, we are not validating that this get summary method works correctly. We are just interested in it providing it data in correct schema. Then we update our dataset summary server function so that we can pass our data provider object. And now onto our assertion. So here I will be using a Selenider package. It is a package that I consider a supplement to Shiny test2. It allows you to interact with an app in a similar fashion as you would interact with a web page using rvest package. And onto our expect summary visible assertion. So let's see what it does. We want to find an object on our page that has ID of summary, and we want it to have a table tag. We also want it to be visible. This is a function from Selenider, and we expect it to have at least one row of data. And this could be just a starting point. This is how we might understand the requirement that it should be visible. If at any point this understanding changes, we can go back to our expectation function and modify it. So now we just add the table output, we add the render function, we call getSummary method, and suddenly tests are green. So in this way, tests are our entry points to the code base. And if we add such a little snippet to our test case with a similar call to a Shiny app as we did in a test case, we can run it interactively. And it actually allows you to work on the interface with a very fast feedback loop. We can rerun this module in isolation very rapidly and do changes very fast. So we can work on it and make the design better. And later, as the complexity of our app grows, we can also use this entry point for some interactive debugging or exploratory testing. So we've built our feature. We started from first red test case. It was failing. We made it pass. We might add another behavior, starting from failing test, then make it pass. We can do as many of those iterations as we need to fulfill all of our requirements. Then we might move on to another feature using the same process. If we also provide a good foundation of unit tests, then we will have a very comprehensive test suite. And notice how those features are isolated. It will allow us to work on all of those features in isolation. So when our code base grows in size, we will still be able to work on them separately. And it will help us maintain the development speed, and it pays back, especially as the code base gets bigger and bigger. So why would you use test-driven development? To get faster development cycles, because we can work on pieces of our code base in isolation. To understand the problem better, because before we start coding, we need to focus on what are the inputs and outputs of our system. And to have confidence that it works, because at every point in our development process, we have this test suite that tells us if our code works as expected. And that will be all. Thank you for your attention. And if you want to learn more about testing and test-driven development, feel free to connect on LinkedIn. Check out my blog where I post about this subject. And if you are interested more in those high-level tests that are focused on user behaviors, go check out my Cucumber package. It might be just what you need. Thank you.
So we have time for any questions?
You mentioned that how we can test, but how do you come up what to test?
So this is when you interact with your client. If you're working with a client, you establish it with them, what they really need, and you need to focus on the behavior of the system. So you can do it via workshops or like asynchronous communication, but there are ways of getting those requirements, and then if you focus on how you phrase them, then it is very easy and convenient to put it into code.
And follow up, if you already have a full app and want to implement it afterwards, any tips on that?
Yes, so then I would recommend going to, Understanding Legacy Code webpage. It has a lot of tips on how you can work with existing code bases and how to extend it. But even if your code base has tests, if your code base has tests or doesn't, you can still employ the same techniques to develop it further. It's just about how you glue this new code to existing one.
Any other questions?
How do you organize the test suite files? Because I can imagine that it can grow pretty quickly. So how do you keep it tidy?
So you're asking how do we analyze what we are already testing, or?
No, just for the code files that contains the tests, how do you organize all the files? Is it like one file per module? Is like, yeah, how do you organize the
So it
directories
depends what you need, but if we are going with this split that I suggested, that each feature is a separate module, you can also have a separate test file for each feature, and then you have those isolated pieces in your code base that you can work on and test separately.
Thank you.
Okay, thank you very much, Jakub.
Thank you.